you can accept it. Okay, also with the instance ID of 2. Okay, now if you check the show LISP site, okay, you can see that for site 1 we learned the 192.168.10 and 20 from the router 1 and router 3, but for site 2 and 4 we didn't receive. We need to find the reason. Let me to check the configuration of the router 2. This is the router 2. Okay, we configured, yes, here in the router 2 we configured the do show run. Look at here, this is XTR2 section router list. We need to find our mistake. I configured database mapping for 192.168.10/24 and then quad 2, it's okay. The R2s are look address and the priority 1 and wait 100, it's okay. Okay, VRFB and then instance ID of 2. Here we don't have any mistake. Do show VRF also can show us that we have only one VRF. VRFB include the ETA01 and the LISP interface. It's okay. Let me to check again the R5 in the show LISP site. Yes, this now the site 2 is added, and it's and I think after some second the site 4 also should be added. But we can check the R4 configuration. Do show run. This is the R4 configuration router list. As you can see, here we have the EID table for VRF, VRFB, it's okay. Instance ID is 2, it's okay. Database mapping 192.168.30, and then quad 4, priority 1, wait 100. Yes, it's okay. Let me check the R5 again, show LISP site. In the router 5, in the show run, about the for example site 4, look at here we didn't configure the authentication key. Let me to add the authentication key, router LISP. Okay, then site 4, we need to add the authentication key. Authentication key is Cisco. Let me to add it also on the notepad file. Here as you can see, we don't have the site 4, we need to add it. Site 3 and also site 4 with the authentication key of the Cisco. So easy. Okay, now let me check again the R5. This is the mapping server, show LISP site. Okay, until now we didn't receive from the router 4, from the site 4, because you know that each 60 seconds the advertisement should be received by the router 5. But if you want, we can check again the running config. Inside in the site 4 we have authentication key Cisco, it's okay, and then EID prefix with the instance ID of 2 192.168.30, it's /24, it's okay. Show LISP site. Okay, show LISP site. Until now again we didn't receive. If you want, you can capture or use debug command for finding the reason of this, because here we can see the EID prefix is the same EID prefix and the instance ID is 2. Okay, and we can check the R4's IP address also. Let me to check it. Do show for example IP interface brief. The ETH01's IP address is 192.168.34, it's okay. And also do show VRF can show us that we have only one VRF, VRFB. And also you know that in the do show run for example section router list, we have the information about the instance ID of 2 that we configured for the VRF. We need to wait some second, we don't have any problem. In R5, yes, now it's corrected, because each of this map register message should send in the 60-second period. Maybe one of them is for a little more time we need to learn them in the R5 mapping server. Very good. Now if you want, you can check the connectivity. Okay, until now we saw the mapping register. Look at here, this is the mapping register, as you know, and in mapping register we saw the instance ID. But about the, for example, data plane again we have the same problem. Okay, the problem is that here we have one physical infrastructure and we need to forward the traffic in one physical infrastructure for two different networks. For example, assume that we are sending a traffic from the PC3 to the 192.168.110. This IP address is available in the VRFB and also VRFA. How other routers can identify this traffic is receiving for example, themselves or itself or other routers. Here again, we need to use the instance ID. For example, when the R3 is sending its traffic to the router 2, in the Lisp header, we need to see the instance ID. Let me to show you. Assume that the R3 is sending traffic to the VPC1, 192.168.110. Also, VPC2 has this IP address. When R3 sending the traffic to the, or encapsulating the traffic to the router 1, okay, the router 1 should first verify the instance ID of the available in the Lisp header. If the instance ID is equal with the instance ID of this VRF, it can accept the traffic. I will show you. Look at here first. Let me to send some traffic from the, for example, VPC1. This is the VPC1. Let me to try to send traffic to the 192.168.210. You know that the 210 or VPC3 is one IP address in the VRFA. Because of that, we expect to have for example, connectivity to this IP address. We need to wait some second. After some second, we can check the result. Yes, we have connectivity to the VPC3. But if you try to the 192.168.310, the IP address of the another VRF, we don't have connectivity. Okay, why? Because from the R5 now we receive one native forward message. Look at here, we sent the encapsulated map request to the router 5 to the MS or MR, and here we receive from this router a Lisp message, and here you can see the native forward action. This means that R5 first verifies the instance ID of the request, and in this instance ID means in this VRF we don't have 192.168.3.0. Because of that, the R5 send the natively forward message or order to the R1. Okay, if you want, you can see them in the R1. We have the show IP list map cache. Here we can use show IP list map cache for which instance? For instance 1. Okay, in instance 1 we have this information. We have information for 192.168.2.0 these networks with the RLOOK of quad 3. It's okay. Okay, but when you asked about the 192.168.3.0/24, you received the forward native action. Okay, and you know the reason of this. After that, let me to try from the VPC2. This is VPC2. If you try to send traffic to 192.168.2.10, okay, you won't answer, you won't give answer. Look at here, very good, it's okay. But if you try to send traffic to the 192.168.3.10, you can. 192.168.3.10. Let me to check the result. And now the encapsulation map request is sent, and after that, as you can see, after receiving the map reply, now we can send traffic to the router 4 and it's working. Also in the VPC2, in the, for example, R2, we can check the mapping cache, show IP list map cache for the instance 1. Here, this is the XTR2. Here we don't have any information about the instance 1, but in instance 2, we have 192.168.2.0 with then forward native, and 192.3.0, 192.168.3.0/24 with the locator of the quad 4. But if you want, you can check the ICMP packets here. Let me to find ICMP packets. In ICMP packets, this is the link between the router 1 and router 5. You can see the traffic from 192.168.110 to the 192.168.2.10. Okay, this traffic is this is ICMP IP and then encapsulated with the Lisp. Here you can see the instance ID of 1. This means that when we are sending the traffic to the for example, destination RLOOK, we need to identify the instance ID of 1, and when the R3 receiving this packet, it should first verify the instance ID, and after that it can forward the traffic inside of the VRFA. Maybe here we have more than one VRF. For example, in multi-tenancy, we need to use this instance ID. As you can see, we have only two new commands here. The first command is the configuration of the, for example, VRFs in their XTRs or ETRs. And also when you want to advertise the EID to the MS here, first you should define one instance ID for each VRF. For example, you know that we are using database mapping command, but here instead of the database mapping command, we need first configuring this command EID table in the router 1.